Okay, hello everyone, and welcome to this special episode of the Gartner Review meeting. This time me and Raphael were honored with the task bringing the Kubernetes 1.35 support to Gartner and extensions. And as we have done it with previous Kubernetes versions, we take this as an occasion to bring some details and more information about the Kubernetes release to you. So yes, this one is about 1.35. To honor the release a little bit, you see here this logo of the release. It's called Kubernetes, the World of Tree release. So what do we see? That there's prominently a tree, which represents the growth of Kubernetes. So as a tree grows slice by slice, the Kubernetes project grows release by release. Then there is the Earth with the Kubernetes logo inside, representing the community, the contributions, and 3 squirrels in front of that, guarding the tree and the world. So the left one represents the reviewers. The one in the middle represents the release teams. They cut new branches with their axes. And the one to the right are with the lantern. It brings light into the world or into the area of complex issues. So it sheds lights on that. There's even more to explanation and to the story. So please feel free to check out the release blog. You'll get more information. I think the maintainers were very creative again. So it's a pretty sweet story, actually. Okay, let's get started with the agenda. So we will begin with what has been graduated to stable in 1.35. We will continue with what has been graduated to beta and what was added completely newly to this release. Then we'll continue with some security, deprecation, and removals, which are important if you switch to 1.35 in the context of Gartner. And yes, then of course also this what changes in that regards. What have we done in Gartner to bring this release and what you need to consider as operators and Schmoot users. Okay, let's start with what has been or what is now considered stable as of Kubernetes 1.35. We'll begin with a very popular feature, I would say, which is the in-place pod resource updates. So you probably all know of these features, of this feature that you can adjust resources on the fly for pods. They get applied without any restarts. So it's been in alpha for quite a while and beta since 1.33. So it's now being considered stable, which is a pretty nice and important step for the project, I would say. And what goes more or less hand in hand is the generation feature on the pod resource or API itself. So you can now track the generation and observe generation for the pod resource like you are used to for every other resources like deployment, stateful sets, and so on. So whenever something changes in the spec, especially also to the resources, the generation is increased by 1. And whenever the kubelet reconciles the new specification, the observed generation is updated as well. So if you rely on such features, you are now can do this in a stable manner. Then we have some updates to the dynamic resource allocation. So what happened here, the core functionality is always enabled now with 1.35, and we have on top of that some updates in specific areas. So if you request devices which are exposed via the dynamic resource allocations and do this via the extended resource requests, there's been some improvements. As well as is a new effect for device taints and tolerations. The effect is called none. So yeah, it helps you to do dry run evictions, especially if you use DRA. Then we have some updates to partitional devices. So if you have partitionable devices, you can now span them across multiple resource slices to represent them accordingly there. And last but not least, there have been some improvements if your device is set up as a or if your device has some consumable capacity in the specification, then there have been some bug fixes and reliability improvements here and there. Okay. Then for the services, there is this traffic distribution specification, which has been in place for quite a while. And a new mode was added to that. It's called Prefer Same Node. So yeah, it helps you to keep the traffic local to the node in case you have, for example, one consumer pod and a pod belonging to a service. And then you can configure it as such that the traffic doesn't leave the node, and to improve latency and maybe also cost, depends on use case. Yeah, and this is in addition to the already known prefer same zone option, I would say. All right, the job API, there is this field in the specification called managed by. So by default, a job is always managed by the job controller in the kube controller manager. And the managed by spec helps you to take control over a job by a different controller. So for instance, if you need to shard a job somehow to distribute the work, for instance, for multiple clusters, and there are other controllers taking over for this job, you can define you can define this field, and then the default job controller doesn't jump in anymore, but instead your custom controller or another controller which is responsible for that job resource. Then if you use NUMA, then this is probably interesting for you. So also here, the Kubernetes has increased the maximum support for NUMA nodes, which was 8 nodes earlier. And yeah, with this field, you are now allowed to set it to a maximum value. Yes, you can set it to true, as shown here. And then you would overcome this restriction, which was earlier in place. And another point which is now being considered stable is that you can compare resource versions. So earlier it was only possible, or it was only supported for simple equality for those resource versions. So you could only check it for equals or not equals. And now it is officially supported to check if a resource version is greater or less than equal to the other resource version, smaller than that, which helps you to actually judge the state of your resource, right? So you can really now judge if you missed some updates, for instance, and if the resource you're looking at is newer than the other resource, which was, for instance, cached somehow. So this is officially supported. And for the sake of completeness, we have various other stuff that has been considered stable as of 1.35. Please feel free to check it out in detail after the meeting. So there's been a ton of other stuff happened in this release. Like the kubelet drop-in directory. The limit of parallel image pulls and so on and so forth. So I don't want to spend extended time on this, but it's, as I said, for sake of completeness, and please feel free to check it out in detail. Right, then I'll hand over to Raphael for the next part.
Yeah, I'm taking over with a beta bloom. So these are now the features that have been promoted from alpha to beta in this release. And we start with exposing node topology labels via the downward API. So the node topology labels are usually some labels on the node that specify in which availability zone and in which region the node resides. And yeah, previously the pods would have to query this information somehow from the nodes. And for this, of course, need permissions. But now there is this support in the downward API. So meaning that you can have, like here in the example in the bottom right, a downward API volume, or alternatively via the environment variables that you probably know a bit more because it's more common. You can just specify the field path to the label, and then you get the information in the pod either as file or as env and can then use it without the necessity to query this proactively. Then the next one is support for native storage version migration. So what is this about? There is this new resource here with the same name and a special API version that you can create in the cluster. And this will basically help you to migrate the objects in the storage layer. So what are prominent examples for that? So one is that you have, for example, a version change in your stored resources. So let's say your preferred storage schema is changing from v1 beta 1 to v1 for a given resource. And you want this to reflect in etcd or in the storage layer. And the second one is, of course, the changing of the encryption at rest. So let's say you have changed your encryption key, then you also have to rewrite the data in order to make sure that it is re-encrypted with a new key. And before this native support here with this resource, you or the client basically would have to perform this rewrite manually. So usually you send like an empty patch. This is also what we do in Gardner. When the etcd key is rotated, we just send empty patches for the encrypted resources to make sure they get rewritten in the storage layer. And only when this is completed, we can basically safely get rid of the old key. And with this API here, it would be much easier in the future. We could just create this object and then Kubernetes will take care of rewriting the data. There are conditions where you can observe the current state. And of course, this will reduce a lot of operational overhead and make the whole flow a bit easier for everybody. So this is more beta. We could probably start trying it out. Next one is about CSI. Here, probably maybe a small feature, but could have good impact on the users. So mutable volume attach limits. Some fields in the CSI node spec have been immutable before and have now been made mutable. And this, of course, allows for better dynamics in the cluster. So scheduler can behave a bit better. And you can configure the retry interval in the CSI driver object. And with this, get a bit better scheduling behavior. Then we have a feature related to the AI workloads that are more and more running on Kubernetes, opportunistic batching. So this is about introducing this opportunistic batching for compatible pods to reduce redundant scheduling. So in the end, this makes the whole scheduling procedure faster. And this was also the main motivation for this improvement, to basically enhance the performance of the scheduling when there are a lot of compatible pods to be scheduled at once, which is sometimes or usually the case for AI workloads. And basically with this also keep building infrastructure that is necessary for gang scheduling in Kubernetes. So how this is done is that the scheduler computes this scheduling signature for the pods, which is something, I don't know how exactly this is done. You can maybe think of it like a hash. And if the hash is similar for the pods, then they are all the same from the scheduling perspective. And then some optimizations can be used. So here in this example, we basically see how this works. So the scheduler schedules the first pod and then schedules the result, caches the scheduling result. And for all the other pods that are there, it can just use the cached result, which is of course much faster, instead of recompute all the filters, plugins, and everything again, and just use this, and this will make the whole process a lot faster. Actually, this was interestingly directly introduced as beta. So, yeah, seems to be quite stable already. Okay, then next one, max unavailability or max unavailable field for the stateful sets. So this is about the new field where you can now control how many pods of your stateful set can become unavailable when you roll the stateful set out to a new version or something. So this is because usually in stateful sets, the pods are just recreated once at a time. And this can, of course, make the whole rolling update a bit slow. And if you have a stateful set or a special workload that can also cater with more unavailable pods, then you can use this feature to basically speed up your rollout, which also was the main motivation for this. Make this optionally faster if your stateful workload can deal with it. Of course, this works best if this pod management policy field, which is another field in the stateful set spec, is set to parallel instead of ordered. Because for ordered, it would use the ordinals of the pods, and parallel, it will do parallel processing of the pods. But the default is still 1, so everything is preserved to as before, and you can just set it if you want to use it. Another feature promoted to beta is this KYAML dialect that Kubernetes has introduced in the last version, which was already presented by Johannes and Tobi back then. I think I just reused the very same slide because there were no significant changes, just that the feature is now being promoted to beta. As a reminder, here's an example on the right. The special things here are, for example, that the value strings are always double quoted, that the keys have no quotes, that you always use these curly braces here for the structs and for the maps, and the regular brackets for the lists. And you have this comma always at the end. So the goal here was to make the whole language a bit easier for the users, because YAML is hard and chased as well, apparently. Okay, next one, support for user namespaces and pods. So this is about the fact that containers often run as root, but that usually means that they are also effectively root on the host if they escape the container, which is a major security risk. And the Linux kernel has introduced this feature called user namespaces some time back, which allows you to map users inside the container to a different user on the host, which means that root in the container is actually a regular unprivileged user on the host or on the node. And this of course enables then workloads that need root-like behavior, but you can not really give them real host privileges with that. The way how you enable this is via this pod spec field called host users. If you set it to false, then this is basically enabled. This feature was already introduced as alpha 10 version spec and only now got promoted to beta, so quite some time. Also the cap number is quite low. It's a long-running discussion apparently, but if it's now beta, probably the time was worth it. Next thing, volume sources. So there is this OCI or image volume, which allows you to pull and unpack OCI images as volumes into your pods. So here in the example, you will see that there is this image reference to some OCI image. And when you mount this in your pod, then you on this path just get this image unpacked and can use it for whatever you want to do with it. So this is a bit easier than just pulling it yourself and makes it available directly in your pod. Of course, it requires this compatible runtime, so which is usually container ID 2.1 and above. But otherwise, this is already usable. Then we have another enhancement that was already discussed since 2015, so since 10 years or 11 now. So this is about preventing unauthorized use of cached image on the node. So what is this about? So some images require pull secrets in order to be used by the kubelet. And the pull secrets are created in the namespace. And now there could be the scenario that a pod in the namespace has a valid pull secret for some image. It gets scheduled to some node. The kubelet uses the secret to pull the image. And then the image is cached on the node. And now just some other pod on some other namespace could also refer to the same image, but without a valid pull secret. But if it, for whatever reason, gets scheduled to the same node as before, where the image is already cached, the kubelet will not validate anything or repull anything and just make the image available to the pod, which should not have access to it. And so this is basically what this feature is about. You can see that there is this image pull credentials verification policy field in the kubelet config. And on the right, you see possible values that you can set. Never verify, basically, as explained here. I don't want to go through it. So there are these 4 modes where you can then control the behavior. And this then even applies for images that, or for pods that specify if not present policy. So if this is a private image, so to say, and it's already cached, then even if not present, the kubelet will try to repull it to see if the credentials are valid. Okay, let's continue. Fine-grained container restart rules. So previously, there was only this restart policy here on the pod spec level, which was then applied to all the containers in the pod. And here the community worked on restart policy and also on restart policy rules on the container level. So you see it here in this example that you can now directly in the container list specify container-specific rules and policies for when containers should be restarted or not. And previously this was just kind of globally for all the containers in the pod. And then the last one is the deployment status, which was enhanced to also count the terminating replicas. So there's now this new terminating replicas field, which will show the pods that are still shutting down. And that's actually also nice for us, because in Gardener we have some workaround because this feature was always missing. And when we want to make sure that the deployment update has really been rolled out, currently we are just listing all the pods ourselves and check which pods belongs to this deployment and if they are still terminating and so on. And with this new field, we can probably get rid of it and just rely on the deployment status, which is much easier to handle. Okay, and then also here are some honorable mentions. Not so many as for the GA section, but at least some more changes, of course. And with that, I hand back to Tim.
Okay, so what's new in 1.35? Raphael already mentioned it in the beta plume with the improvements to the Kubernetes scheduler. So it has been, or the scan scheduling support has been added in 1.35. So normally, if you have workload, which is spread across various pods, let's say it this way, then the pods are scheduled one by one by the kube scheduler, and if a portion of these pods cannot be scheduled anymore due to some resource shortage in your cluster, then they will remain in pending state for the time being. So as long as there's no resource available, or until when there's resource available again, the pods will be scheduled, but only then, which is obviously a problem if you have workload which cannot deal with that efficiently. For instance, AI training jobs or similar jobs where you always want to have the entire set of workload being scheduled to the cluster. So what this feature allows you to do is to form such a gang, right? So there's a very nice example here on the slide. It's the you can do this via workload resource, and can specify a pod group. So for instance, in this example, we have the pod group called workers, and we want always a min count of 4 of this pod group being scheduled all together. So that means it will only continue if there are enough resources to schedule all of the 4 pods in the cluster at the same time. If not enough resources are available, or if not the right nodes are available at that time, then it won't continue. So all in all, the entire workload will remain in pending state until the constraints can be fulfilled. Yes, as I said, I think it's a very important feature, especially for running AI workloads in the cluster, training shops, such like that. There's now an alpha state. Okay, then there have been some improvements or refinements in the impersonation feature. So impersonation means that you use for instance, a kubeconfig, which is bound to some user, and the impersonation allows you to execute commands on behalf of another user, on behalf of a service account, on behalf of whatever, however that user is authorized in the system. And before this change, or before these refinements that you can see on the slides, it was only possible to have it all or nothing. That means either you could impersonate someone or you couldn't. And the refinements added in 1.35 allows you to specify, for instance, that you can only list certain resources on behalf of the user, or you can only create certain resources on behalf of the user, and so forth. So in this example, there is this role here. It's it is a rule for pods, and saying that you could impersonate that user, and the impersonation is regarding the list and watching pods. So for instance, we can we can bind that via the role binding underneath. That binds the service account and gives it access to the impersonation of listing and watching pods, right? So you could use the use config with that service account and execute the kube control command get pods, and impersonate it with that user. So it adds more flexibility and gives more finer control over what you want to allow when it comes to impersonation. Next is very handy feature when it comes to troubleshooting and debugging. So there is this flag Z endpoint in this example for the Kube API server, but also for other components in Kubernetes like Kube Controller Manager and so on. And at this time, it gives you structured output and machine readable output when you call that endpoint. So as far as I know, the endpoint was already partially there, but it gave you unstructured output. So, and in this case, you could call the endpoint, And for the flags here, you get all the flags that were used to start the Kube API server, right? So if you have a cluster which has some issues, for instance, you could call this endpoint and figure out the flags and get more information about this instance. I mean, usually you could also go to deployment directly, but this is, yeah, I think gives you other options to do troubleshooting and debugging during runtime. If you're not having access to the deployment or to the pod. Very similar. It goes for the status C. So also here it was structured output was added, and yeah, unlike the flag C, which gives you all the flags, this one gives you a status overview for the component. So here again in the example we have it for the Kube API server, and it gives you information like when has the Kube API server instance started, the uptime seconds, the Go version it was built with, and so on and so forth, right? And the other paths available for this component. So I guess, or again, a very handy feature when it comes to troubleshooting, debugging, or whatever you need to do with that kind of information. Okay, then there were some improvements in the job API. So this time you can adjust the resources in jobs which are suspended. So one example would be you create a job, you notice that something goes wrong with the job itself because the resources are not high enough. Then you can suspend the job, you can adjust the resources, and you resume it, right? So it gives you more flexibility dealing with the very same job resource without losing the history of the job. So earlier you would need to create it to delete the resource, recreate it again, but then you will lose history. And with this feature, it allows you to do the modifications in place and keep the very same object. Okay, and here again, the honorable mentions, only two that we listed here. So the first one is that now the Cloud Controller Manager has a watch-based route controller, enabling faster reactions to changes. I think we all, those of you who wrote controllers already know what this semantics is about. Earlier, it was just a static retry mechanism. Let's put it this way. I think it was 10 seconds. So every 10 seconds, the reconciliation started again and again. And this time we can react to events. And we have some extensions to the toleration operators. So now the operators being used in tolerations were extended by greater than and lower than. So you can evaluate thresholds with these new operators, which is a nice feature to tolerate certain taints that are in place. Okay, then back to you, Raphael.
Yeah, let's continue with security deprecations and removals. So we start with the deprecation of the IPVS mode in kubeproxy, which once was introduced for faster load balancing. But yeah, the reason that this is now deprecated and will be removed eventually is that the SIG network actually lacked maintainers that are familiar with IPVS. And so this is one reason. And the other one, that NF tables was always meant to replace it at some point in time. And yeah, combined, this is now leading to this development. So you are encouraged to migrate to NF tables instead of LPBS if you are still using it. Another one, final call for containerd v1.x. So this is mainly about the C group driver behavior. So because before both containerd and kubelet had to configure the C group driver because they were both managing C groups, so either C group FS or systemd. And as part of this cap, it makes also sure that the kubelet just auto detects the driver that is already used by containerd, so that you no longer have to specify it in the kubelet config a second time, basically. And with that, you can, of course, prevent configuration issues and mismatches. Then, of course, the Nginx ingress retirement. It was again made very prominent in this release because it will also go in effect in 3 weeks. In 2024, it was already announced that the maintainers plan to wind down their investments in the ingress Nginx controller in favor of the gateway API. And as you probably know, it is decided that it will go or will basically retire end of March. And until then, there's just best effort maintenance. The guidance actually is to migrate to gateway API. And yeah, if you want to learn more, there's this blog post, but I guess most of us already know. And yeah, the removal of the C group v1 support. So in favor of v2, this is just following the movement from the Linux community, who are basically phasing out the v1 support. And this workstream here is about adapting the kubelet for the same, so that it only works with C groups v2 in the future. And one more, actually, a thing we wanted for years, if you look at this. So we have discussed this already back in 2020 and 2021. The behavior before, when the kubelet was restarting, was that it set the started and ready states to false for all the pods when it freshly started up. And then it performed the probes again for all the pods and updated the states. So usually this led to a short service outage because the pods were for a short amount of time marked as unready or unstarted or whatever. And back then in the time, we already pointed this out together with others, but the community was not too willing to work on this. So nothing happened for quite some time. But now with this cap, finally this behavior is changed. So when the kubelet starts up, it no longer should disrupt the pod readiness. Container states are just kept as they are. And with this, hopefully these short outages should be history. Okay.
All right, so what's changing in Gardener when you switch to Kubernetes 1.35? So we need to, as always, do some changes here and there, depending on what has been removed, deprecated in that release, and also bring maybe some API changes sometimes. So let's go over the list. So there are no more entry add-ons in the shoot. So when you switch your shoot cluster or you upgrade your shoot cluster to 1.35, you have to remove the add-on section. So earlier, the add-on section contained the Nginx ingress controller, as well as the Kubernetes dashboard. So it was a handy feature for people or for shoot owners to just turn on that features. But as we recently learned, the Kubernetes dashboard is not maintained anymore. And the Nginx ingress controller, it's the same for it. So we need to drop the support here. There is no replacement for the Kubernetes dashboard. And for the Nginx ingress controller, there will be a drop-in replacement available with traffic, but it will be a Gardener extension. So as I said, it won't be a part of the add-on section anymore. The add-on section would then be empty, and we decided to entirely remove it from the shoot spec. So if you're using the add-ons, please consider switching for these individual add-ons and remove the section once you upgrade to 1.35. If a shoot is forcefully upgraded from 1.34 to 1.35, then the section is automatically removed, which can be a surprise for users or shoot owners. So that's why we recommend strongly to check the changes beforehand and react accordingly. Okay, then as Raphael said, the IPVS mode in kubeproxy has been deprecated in this Kubernetes release. And thus we also don't allow to set it anymore once you update to 1.35 or you create shoot clusters with 1.35 and beyond. In case you are on IP tables and NF tables before and you consider switching to IPVS in an earlier Kubernetes version, we added a warning for that, right? So to tell users, hey, please reconsider your decision moving to IPVS because IPVS will be deprecated in the 1.35 and eventually removed in the future. So we want to already warn them to not switch today, even if you're not, even if you're on an earlier version, because we don't think it just doesn't make sense to give people the option and then tell them a few releases later, hey, you cannot use it anymore. So best practice is if you're on IP tables and want to switch, go to NF tables, of course, but not to IPVS. Okay, then some smaller removals, I would say. Two fields are not allowed to be set anymore with Kubernetes 1.35 in the shoot specification. One is the default for watch cache sizes, and the other one is the kube max PD vols field. So both fields where they had non-effect for a really long time. So you see here, here it's already Kubernetes 1.25, and here it's 1.17, right? Really old versions. So even if you had set those fields before, they hadn't had any consequences or weren't respected by Kubernetes since those versions. And thus we decided to remove them eventually. And as I said, you must not set them anymore with 1.35. Okay, then there's another change. Earlier we had this field in the Kube API server configuration of the shoot cluster enabling anonymous authentication. So it was a simple field. And this field was deprecated with the switch to Kubernetes 1.32. And we since then have been advising shoot owners to switch to the structured authentication. So basically to a config map based configuration where you can still enable anonymous authentication. So it's just another approach of doing it. And with the switch to this Kubernetes version, we obliged users to do that. So we are not supporting that field anymore. So if you still want to use anonymous authentication, you have to do it with this config map with structured authentication. There's no other means to accomplish that. Okay, so those were the parts about the changes, and then some words about the availability, some general information. The support for Kubernetes 1.35 has been added with Gardener 1.136. So it's always the general support is available in this release. And on top of that, of course, you also need the support from the provider extensions for the new version, for the new Kubernetes version. Two of them were already released. It's the AD Cloud and the AWS provider extension. And the other ones are about to be released soon. So in case you are setting on the non-released providers yet, please be patient for another few days, and yeah, you will eventually get the release to start with the Kubernetes 1.35 eventually. All right. That was it about the news, updates, and celebration about Kubernetes 1.35 from me and Raphael. In case there are any questions, I think we have a few minutes left. So please feel free to unmute yourself and post your questions or ask your questions. In the meantime, I want to say for the record, we want to thank the Kubernetes project and maintainers for being such a great project and bringing out so many features and keeping it the way it is. All right, I don't see any questions from the call. Vetran raised his hand. Vetran?
Sorry, I just wanted to applaud. Thank you very much for all the effort.
Okay, thank you, Vetran. All right, if there are no more questions, open questions, then we can close for today, right? Thanks for attending and have a good day. See you next time.
Thank you. Bye-bye.
Thank you
Thanks
very
for
much.
preparing. Bye.